Okay, 47. So we have a helicopter that's descending steadily. So what does the word steadily tell us? Constant speed. So, okay, so we got this helicopter. Your picture does not have to be pretty. So here's the helicopter right here. So we're sign convention. Down is negative, up is positive. Okay, so velocity for the helicopter is negative 1.5 meter per second with an acceleration of 0, right? Because if the helicopter is not going faster, not going slower, it has 0 acceleration. Okay, so this data right here, I'm going to box this. This data right here is for the copter, the helicopter. Now, there's a package that was attached to the helicopter. So this box under the helicopter represents the package, and it's being released from the helicopter. So let's put down data for the package here. So what's the velocity? What's the initial velocity of the package? Negative. It's not 0 because it was attached to the helicopter, which was at negative 1.5. So if the package was attached to the helicopter, it had the same velocity as the helicopter. So the starting velocity for the package, so I'm going to label this package data. So here's our data for the package. It gets released. What is the acceleration of the package after being released? Negative 9.8. It's going to be accelerated by gravity, right? Okay, so now we're asked to find the velocity of the package, the speed of the mail bag after 2 seconds. So the time we're focusing on here is 2 seconds. So how do we do part A? Part A, we go this kinematic. VF equals V initial plus AT. So show your equation, then plug in. So VF equals V initial. What was V initial for the package? Negative 1.5 plus, and then the acceleration's negative, just meaning down, 9.8 meter per second squared for a time of 2 seconds. So we get a V final of 21.1, negative 21.1 meter per second. And technically, you actually don't need this negative here if you're really on your physics game. Notice it says speed. Does speed have a direction? No. So you could just say 21.1 meter per second. The negative just indicates down. Okay, question B. How far is the package below the helicopter? You cannot do this in a single calculation. You got to calculate 2 things to do this. All right, so I'm going to erase this first calculation. We're done with that. Okay, part B. 2 calculations. The first calculation is find how far the helicopter drops. How far does copter drop in 2 seconds? And then the next thing we're going to calculate is how far does the bag drop in 2 seconds? Okay, because they have different accelerations. All right, so finding how far the helicopter drops in 2 seconds, we go x equals 1/2 at squared plus v initial t. What's the acceleration of the helicopter? 0, because it's moving at a steady speed, not going faster, not going slower. So we get x equals v initial times t. So that's negative 1.5 meter per second times 2 seconds. So we get negative 3 meters. What does that negative mean? Down. The negative just means down. Okay, how far does the bag drop in 2 seconds? X equals 1/2 at squared plus v initial t. So we're going to just plug into this. 1/2 negative 9.8 meter per second squared for a time of 2 seconds plus initial velocity is negative 1.5 for 2 seconds. All right, I just plugged in there. So that comes out as negative 22.6. And again, the negative just means that it went down. So, how far apart will the helicopter and the package be? Well, the helicopter went down 3 meters. The package went down 22.6. You guys getting this? So look, the helicopter went down 3 meters. The package went down 22.6 meters. So how far apart are they going to be? The difference between those, 19.6 meters. Yo. Oh, no, that's a plus. Sorry. I messed up. That should be just a plus. I was just plugging into this equation right here. Okay. Any questions on this part? Now, for part C. So for part C, we're going to redo the whole thing, but now the helicopter is rising steadily at 1.5 meter per second instead of dropping steadily at 1.5 meter per second. So how do we do part C? So let me shrink this down. So, yo.
Wait, if it was on a test for the answer to be correct, we have to do negative 3 meters down, but show like we understood it was going down.
If I were asking for the magnitude, on test, it's pretty common, like on exams, where like the answer choices are like A, 22.6 meters, B, negative 22.6 meters. You'll see that on answers, like where one is plus and the other one's minus. And the only difference between them is the direction. Okay, so part C, we're figuring out the velocity of the mailbag if it were initially going up. So part C, you go VF equals V initial plus AT. So V final. Now what's V initial? If the helicopter was going up, then that's a positive initial velocity, right? So change that to positive. This is still negative. That's still going to be negative because gravity's still down. Okay, so V initial is positive 1.5 meter per second. Acceleration's negative 9.8. Don't tell anybody. I'm going to leave the units off here because I'm out of room. For 2 seconds, like that. So here, meter per second squared, 2 seconds, like that. So then V final comes out as negative 18.1. Okay, that's if the velocity were initially up. And then to refigure out how far apart they are, if the velocity were initially up, all you got to do is go back to these calculations here. Go back to these calculations and just do what? Make the initial velocities what? Positive. Just change that to positive 1.5. When you change this to positive 1.5, this comes out as positive 3. Positive meaning up, and then go to this calculation, make this positive, which changes this answer here. So if the initial velocity is positive, this comes out as negative 16.6 meters. So look, here's what happened. Let me diagram this for you. So if the initial velocity were upward, so the helicopter did what? The helicopter went up 3 meters, right? The package went down 16.6. So how far apart is helicopter from package? Still 19.6. And I think that's just a coincidence, that the fact that they're still 19.6 meters apart. That's coincidence.